For years, sailboat design changed slowly, until now. This new 2026 model claims 7.8 knots upwind, a 40% cut in carbon dioxide emissions, and cockpit automation that outpaces anything from Beneteau or Jeanneau. But can these radical numbers actually deliver, or is the industry's biggest promise still just marketing? To find out, we have to start at the hull, where everything you know is about to be challenged. Naval architecture starts with numbers, not promises. The new 2026 hull was conceived around a single question: how much speed can you unlock from a production cruiser without sacrificing comfort or safety? The designer's sketches, drawn after a sleepless night in La Rochelle, set out to challenge the Hanse 410's reputation for blending interior volume with real upwind pace. The result is a hull geometry anchored by a sail area to displacement ratio of 21.5 and a displacement to length ratio of 170. These numbers are not abstract, they translate directly to velocity made good. On the test course, the new boat posted 7.8 knots upwind, outpacing the Oceanus 37.1 by nearly 3/4 of a knot, and matching the Hanse 410's best runs, despite carrying more living space aft. The wide stern and pronounced Chinese are not just for show, they actively increase the effective waterline as the boat heels, maximizing drive and minimizing drag. Every angle, every curve, was tuned for a single goal: deliver more speed per square foot of sail with less wasted motion. For a designer, seeing these numbers confirmed in sea trials is the moment theory becomes reality. The hull's efficiency is not just a claim, it is stamped in the logbook, visible in the wake, and measurable against every major benchmark in the 35 to 42 foot class. Inside the factory, the new hull takes shape under a regimen that is far removed from the old hand-laid fiberglass of Bavaria's C-42 upgrades. The process begins with vacuum infusion, a method that draws resin through every layer of glass and carbon under negative pressure, eliminating air pockets and excess weight. This is not just about clean lines or a perfect finish. Each pass of the resin, monitored by sensors and time-lapse flow gauges, locks the carbon grid into place along the chainplate floors and high-load paths. The result is a structure that in bench tests shows a validated gain in torsional stiffness, 25% higher than the best numbers from the previous C-42 layup. The environmental argument is just as rigorous. Third-party life cycle audits, while still rare, support the builder's claim of a 30 to 40% reduction in total carbon dioxide emissions compared to traditional methods. That figure comes not only from using recycled carbon and bio-based resins, but also from slashing waste and energy use during the cure cycle. The contrast is stark. Where the C-42's partial infusion and classic grid rely on more manual labor and higher emissions, this new regimen sets a benchmark for both sustainability and structural integrity. For owners, these choices have real consequences. A stiffer hull means fewer creaks offshore and tighter control in heavy air. But the advanced composite grid also brings questions about repair costs and long-term service, a debate that echoes through every charter fleet manager's spreadsheet. The silent hero here is the process itself, quietly reshaping what is possible for the next generation of production cruisers. Sail handling on a modern cruiser often comes down to moments of pressure, reefing as the wind climbs, trimming for a sudden gust, or tacking solo with one hand on the wheel. The new 2026 model was engineered to compress those moments into safer, simpler actions, and the numbers tell the story. In instrumented trials, the time to reef the mainsail dropped by 23% compared to the Jeanneau Sun Odyssey 380's latest refresh. That is not a marketing boast, it is a measured cycle. Mainsail fully deployed to double reefed, lines led to the helm, stopwatch running. The average time fell from 104 seconds on the Jeanneau to just 80 seconds on the new boat. Load sensors mounted at key points on the rig recorded a 12% reduction in peak sheet loads during these maneuvers, meaning less force is needed at every winch and clutch. For sailors, this isn't just comfort, it is a real drop in risk. fewer strained backs, fewer jammed lines, and a lower chance of gear failure when conditions turn ugly. The Autopilot and Trim Automation Suite delivered another measurable gain. On average, each correction saved 18 degrees of unnecessary helm input per maneuver. That is less oversteer, less wasted motion, and a more consistent heading when sailing solo or with an inexperienced crew. The Jeanneau 380 set the standard for ergonomic deck layout in its class, but it still requires two hands for a full reef underway. The 2026 model's push-button system, paired with integrated sensors, allows a single sailor to manage every sail evolution from the helm. No need to leave the wheel or call for help. These are not theoretical gains. They show up in the logbooks, the muscle memory of crews, and the safety margins of offshore passages. When the workload drops and precision rises, the result is a boat that expands the boundaries of who can sail and how far they will dare to go. Stepping below deck, the difference in usable space becomes immediately apparent. The new 2026 model delivers a forward berth with 19% more cubic volume than the Beneteau Oceanus 37.1, a figure confirmed by independent volumetric surveys. This isn't just about a bigger number on a spec sheet. It translates to an environment where two adults can move, dress, and stow gear without the awkward contortions familiar to owners of previous generation cruisers. The modular bulkhead design allows the berth to convert from a private stateroom to an open lounge in less than a minute, using quick-release latches and sliding panels. In practical terms, families gain a flexible space that adapts to changing needs over the course of a passage, while charter crews can reconfigure for privacy or communal gatherings without tools or frustration. Ventilation and light have also been rethought from the ground up. Instead of relying on a single overhead hatch and side port lights, the new model integrates a cross-ventilation system. Twin cowl vents feed fresh air through ducted channels, while low-profile hatches at both bow and stern create a steady airflow even at anchor. The effect is most noticeable in humid climates, where stagnant air and condensation can turn a cabin into a sauna. Owners and charter managers report that even after a week at sea, bedding and upholstery stay dry, and the saloon remains comfortable without constant use of powered fans or air conditioning. The galley and head layouts benefit from this same attention to volume and flow. The galley's working triangle has been measured and optimized so that movement between sink, stove, and refrigerator requires fewer steps than on the Oceanus 37.1, reducing fatigue during meal prep. Storage lockers are deeper and more accessible, and service hatches to water and waste tanks are positioned for one-handed access. These changes are not just theoretical. They show up in owner diaries, where the daily rhythm of life aboard feels less cramped, less cluttered, and more in tune with the promise of long-distance cruising. For anyone who has spent nights at anchor wishing for a breath of cool air or an extra inch of elbow room, the payoff is immediate and unmistakable. Annual maintenance for a next-generation cruiser now averages 54 hours per year, according to service logs from leading charter fleets. That number stands in sharp contrast to the 60 to 85 hours required by older models, and it reflects the impact of modular systems and remote diagnostics. But for owners, time is not the only cost. When a key part fails, the wait for a replacement can stretch to 8 weeks, especially for bespoke electronics or specialized hardware. A charter manager's spreadsheet lays out the fiscal reality. Repair costs for advanced composite and automation systems run 2 to 4 times higher than the do-it-yourself baseline set by Catalina's long-standing reputation for owner serviceability. Labor rates, certification requirements, and proprietary components all feed into the multiplier. Even with digital twins and predictive maintenance, the economics remain unforgiving. Every hour of downtime and every delayed part translates directly to lost bookings and increased operating costs. The promise of low-touch ownership is real, but the numbers demand scrutiny. Cape Hatteras delivered the perfect test, a 35-knot squall, steep seas, and only one sailor on deck. The sensor log captured every second. Wind alarms sounded at 2:17 a.m. The mainsail, fully powered, dropped to a double reef in just 90 seconds, with no crew called up and no one leaving the helm. Rig load sensors showed a spike, then a sharp drop, and peak sheet loads fell by 15% once the sails were trimmed. The real surprise was the workload metric. Compared with manual control, the system cut physical effort by 40%. One hand managed the lines, the autopilot corrected for every gust, and the boat kept its heading through the worst of the blow. There were no missed tacks and no gear failures, only a minor sensor calibration error logged for review. By sunrise, the logbook told the story. A single sailor, hands unbruised, had steered through the storm with every critical maneuver executed under pressure, and the hull remained unscathed. For an industry where progress once meant inches, today's leap is measured in carbon, code, and control. As sustainability and smart tech redefine every voyage, the real test is adoption, not invention. What will it take for these breakthroughs to become the new standard at sea? Let us discuss.